Hello, I'm Mr. Black. This video is a video that documents a summer camp I did this summer. It was a camp to apply a parabola. And what we did was we learned how to map a projectile and then accurately predict where the projectile was going to go. And the summer camp ended where I get smashed by water balloons. So I hope you enjoy. Yeah.
My name is Trey and I'm at Mr. Black's math camp at Van Damme Academy. I built this trebuchet and then I did a test shot with this clay ball and determined the vertex of its path. I then used that to build this equation and decided that I wanted to see how tall a target would have to be if it was 160 centimeters away, and determined that it would have to be 37.5 centimeters tall. I've set my trebuchet 160 centimeters away from the table, and the target has to be on top of the table because the clay ball releases at the height of the table, and the popsicle stick indicates 37.5 centimeters above the table.
Hi, my name is Sam. I'm in Mr. Black's Catapult camp at Van Damme Academy. I built this hydraulic catapult and we did a test launch and determined the vertex of the trajectory. I used my vertex to make this equation, and from that equation I deduced that the target would be 32.3 centimeters high if the catapult was 170 centimeters away from the target. The catapult 170 centimeters away from the target. The target is using books to hold up the cups, because when the catapult fires, when the arm is at its highest, when it launches, it's the same height as the books, and we have to make up for that. So the cups are exactly 32.3 centimeters high, so when you launch the catapult, it should hit close to the top of the cups.
All right, here are Luke's targets. We put some rocks in them because Luke is shooting a clay projectile from his trebuchet that is positioned 275 centimeters away from this 23 centimeter high target. We placed the target at this height and the trebuchet at that far because during a test shot we observed the vertex of the trajectory of Luke's projectile to be at 157 centimeters away from his trebuchet and 51 centimeters above. All right, let's see if this works. Hello, you just watched a video of us deploying catapults that we had built in the classroom. We built a grid on the whiteboard and shot the projectiles from the catapults in front of the whiteboard so that we were able to determine where the vertex occurred of the projectile's trajectory for each catapult. We then used the coordinates of the vertex to build the vertex form of the equation. Once we had our equation that represented the particular projectile for each catapult, we used that information to predict how far away we should put a target of a particular height and how high we should make a target from a given distance to the catapult. What you saw in the video was us building and using targets of a particular height from a given distance from the catapult. However, what you're about to see is us getting smashed by water balloons launched from a much larger catapult than any of the ones featured in the video that you just saw. I built a large catapult so that we could launch water balloons at each other. In particular, the students were looking forward to hitting me with a water balloon. And what we did was we launched the catapult, the large catapult, once, and we filmed it in slow motion to get an idea of where the vertex for this water balloon was. We used that information to then predict how far away I need to stand or somebody around 5 feet needs to stand in order to get hit by a water balloon. So that's what you're about to see, is us getting smashed by water balloons. Our calculations were correct, and it was a great time.
That was good. That's a win.